Alright, so in this video I'm going to continue my discussion of periodic trends, and the first trend I want to go in detail in now is going to be called atomic radius. So we have atomic radius. So atomic radius, that is nothing more than basically the size of the atom. So if I got some particular atom, maybe it's, and I basically have a circle or a sphere, I have R. So basically we're talking about the distance from the nucleus to the outermost valence electron is roughly what the atomic radius is going to be. Now that is something that is actually quite difficult to actually measure. So the way this is commonly done, you can imagine, for example, two atoms bonded together. You know, maybe we have this atom, maybe we have this atom, they make a bond between them. If you know the distance between the nuclei, you know the distance there, the distance d, between the two nuclei, the two atoms, we'll take d, divide that by 2, that'll tell us what the radius of an individual atom is. This is the way it's more commonly done. You have to recall that these orbitals, for example, are kind of like a fuzzy shell. You don't really know where the boundary exactly is. This is a mathematical model, so it's not a hard sphere, it's an electron cloud, which is very diffuse. Alright, so first thing we have to understand about atomic radius. This, again, you learned this back in introductory chemistry. If you go down the periodic table, you remember we have hydrogen is 1s1, lithium is 2s1, sodium is 3s1, potassium is 4s1, rubidium is 5s1, cesium is 6s1. So again, I'm talking about the valence electrons here. So the number in front, for example, 1s1, 2s1, 2 is larger than 1. Basically what this says, the 2s orbital is larger than a 1s orbital. So this is the picture for 1s orbital. The 2s orbital would be, larger in size. You can also think of this in Bohr's model of the atom. You might recall in introductory chemistry we talked about these energy levels. We had the first energy level, second energy level, third energy level, and the point is, as you get further out, as you have more energy levels, the distance from the nucleus to the last energy level increases. So the point is, going down the periodic table, top to bottom, atoms increase in size. So I have increase. So you can write this. Alright, so the atoms increase in size going down. Now left to right, you might recall from introductory chemistry, as we go left to right, what else are we increasing? What else is going up? And notice we got lithium's got 3 protons, beryllium's got 4 protons, boron's got 5 protons, carbon has 6, nitrogen has 7, oxygen with 8, fluorine 9, and neon with 10. So going left to right, I'm actually adding more protons. Recall protons have a positive charge. So since I'm adding electrons now in existing energy levels, we call Bohr's model, the second row, if that's the first energy level, there's a second energy level. So energy level 2 is larger than energy level 1, but I'm also adding my protons. So as I go left to right, I'm adding electrons in an existing energy level or an existing ring. The higher positive charge is going to tug these electrons in tighter as you go left to right. So the point is that atomic radius gets smaller from left to right. So we're going to have a decrease in size left and right for atomic radius. Decrease. That's the basic trend you have to understand. So a question on the test could be, here's 3 or 4 atoms. Can you rank them from largest to smallest? So for example, maybe I gave you rubidium, magnesium, boron, and helium. If you were asked to rate them from smallest to largest, the smallest one would be He, helium. Helium is smaller than boron. Boron is smaller than magnesium. And magnesium is smaller than rubidium. Something to pay attention to. So again, on the exam, go ahead and circle these things if it helps you. Then you can identify what's going on with atomic radius.